Okay, 15a, we have a nice differential equation to solve for 7 marks. So the height, x meters, of a column of water in a fountain display satisfies the differential equation dx by dt is equal to 8 sine 2t over 3 root x, where t is the time in seconds after the display began. We want to solve the differential equation given that initially the column of water has 0 height, giving our answer in the form x equals a function of t. Okay, pretty tricky. So, first off then, we got dx by dt is equal to 8 sine 2t over 3 root x. So on the right, this thing contains t's and x's. So what we need to do first of all is get everything with an x on the left, everything with a t on the right. So if we multiply by 3 root x, we get 3 root x dx is equal to 8 sine 2t dt. Okay, 3 root x is 3x to the power of a half, and then that is 8 sine 2t with respect to t. Okay, so what we can now do is integrate on both sides. So we get 3 times the integral of x to the half with respect to x is equal to 8 times the integral sine 2t with respect to t. So, on the left, we got 3 lots of, well, x to the half integrates to x to the 3 halves. And then we divide by 3 halves, which is 2/3. And then on the right, well, sine of 2t integrates to minus a half cos 2t. And then, don't forget, we have our constant of integration c. So, let's sharpen this up a bit. 3 times 2/3 is 2. So we got 2x to the 3 halves is equal to 8 times minus a half is minus 4 cos 2t add c. So what we need to do now is find the value of c. Now remember, the question told us initially the column of water had 0 height. So we know when when t is equal to 0, the height x was also 0. So we get 0 is equal to minus 4 cos of 0. Cos of 0 is 1, so we get 0 is minus 4 plus c. Therefore, c is equal to 4. So, now we know them. change colour. So now we know that 2x to the 3 halves is equal to minus 4 cos 2t add 4. Okay, so from here we now need to make x basically the subject of this formula. So let's first of all divide through by 2. So x to the 3 halves is equal to, I'm going to rewrite the right hand side of it. 4 divided by 2 is 2. Minus 4 cos of 2t divided by 2 is minus 2 cos 2t. Right, so now we need to undo this power. So to undo a power of 3 halves, let's first of all square both sides. So x cubed is 2 minus 2 cos 2t squared, and then to undo the cube root both sides. So we get x as a function of t is equal to 2 minus 2 cos 2t to the power 2/3. Good times. Okay, and now part B wants us to find the maximum height of a column of water to the nearest centimetre. Remember, x is metres. So we want the maximum height. So, using what we've just worked out, we know what x is as a function of t. So we need to make 2 minus 2 cos 2t a maximum. So let's think about the values that cos of 2t can take. It can be between minus 1 and 1. So 2 cos 2t is between minus 2 and 2. Now, in the function of t, we are subtracting cos or 2 cos of 2t. So for 2 minus 2 cos of 2t to be maximum, we want 2 cos 2t to be minus 2. So the max height is 2 minus 2 to the 2/3. So that gives us 4 to the 2/3. Now if we smash that in our calculators, we get 2.5198. Now that is meters, so to turn it into centimeters, we multiply by 100. So in centimeters, the max is going to be 251.98 centimeters, which to the nearest centimetre is 252. Cool. Question done.